So what we're looking at today is the inner workings of a SpectroVis or a SpectroVis Plus. Normally I wouldn't plug equipment in and take it apart, but I feel safe enough to do this. And the goal of the video is to show you what's happening on the inside, so it's not just a magic black box. So what we do is we put our cuvette sample in the sample slot there, the cuvette holder. You can see that there's a light on this side, and then it's going to measure the absorbance or the transmittance on the other side. So I took this one apart, and there's a couple important pieces on the inside here, so I want to show those. If I take out the cuvette, you can see that the LED light is housed in here. And if I bend this up, you can see that that light shines through here, goes in one side of the sample and out the other. Now it's really important when you start up this instrument, it's going to ask you to warm it up for 90 seconds. That's really important, just so that you're getting a nice, even, full spectrum of all the colors of the rainbow, Roy G. Biv. So the light gets passes through this tiny little opening here, and then it goes through a series of diffraction gratings, so to focus the light and to bend the light at certain angles. Normally in the past, if we were using a Spec 20, you would turn a dial for whatever wavelength you wanted, and if that would change the angle of this diffraction grating here. So that's going to bend the light at certain angles. So what's going to happen, let's say you have the wavelength set to 400 nanometers. All the colors of the rainbow are coming through here. Violet light would get bent the most, and then it would hit the detector over here. Now the cool thing is, because this detector can basically measure all colors of the rainbow at once, the various colors of the rainbow go through the diffraction grating. Red gets bent less, so it's going to be detected over here. Violet would get bent the most and be detected over here. So that's a really important part of this piece of equipment. We've got the detector over here that's measuring the intensity for each color of the rainbow. Again, I think red is over here, Roy G. Biv, and violet would be on this side. So then what happens is, when you put in your sample, we can't have all this outside light skewing our results, so I'm going to put the black cover back on. And let's say we're going through a yellow sample. Again, if we've already previously calibrated it, we've subtracted out any of the solvent, which would be distilled water, and the plastic cuvette. It's going to read what colors are being absorbed by this yellow light, and or this yellow solution. And when we take a look at our absorbance spectra on Logger Pro, sure enough, we see a peak in the opposite end of the color wheel. So yellow is the color of the solution. Opposite of that on the color wheel would be violet. So sure enough, it's strongly absorbing violet, and it's very weakly absorbing yellows, oranges, and reds. So hopefully this gives you a better idea of what this SpectroVis is doing kind of under the cover.